Humanity has spent thousands of years understanding billions of years of universal history. Here's a dizzying look at why the cosmos spin the way they do. For the why behind this rotation contemplation, we're going back to the days of German astronomer Johann Kepler. He's the guy who figured out that planets don't orbit the sun in perfect circles, but rather ellipses. Those oval shapes mean that planets speed up as they approach the sun's gravitational pull and slow down at their farthest points, but that doesn't explain the rotation of the planets themselves. When the solar system formed, every single particle of that huge cloud of gas and dust had their own little direction. Well, over billions of years, that cloud collapsed and formed a big swirling disk that averaged out into one singular direction. That's our old friend angular momentum at play, and as planets condensed and formed, they sort of took part of that momentum with them. The gas giants of Jupiter, Saturn, Uranus, and Neptune have the lion's share and spin faster on their axes as a result. Now we know Earth takes 24 hours to rotate relative to the Sun and 4 minutes shy of that relative to the stars. Jupiter takes the top speed prize with a little under 10 hours for one rotation. That, combined with how much larger it is than our home planet, means you'd be moving 27 times faster at the equator there than here on Earth. Uranus is the only planet in our neighborhood with a sideways axis, which makes seasons there rather extreme, with each pole plunged into darkness for 21 years at a time. Venus is an odd one for how slow it moves. In fact, at 243 days, it takes longer for the planet to rotate than it does to revolve around the sun. It also has a kindred spirit in Uranus for rotating in the opposite direction from the other planets. Some scholars believe those two have been spinning in the same direction as the rest this entire time, but flipped on their axis some time ago. Others think they simply reversed course. That change could have come from a giant collision from another body to send it the other way, as is the leading theory for how our moon was formed. Though over time, the moon has become tidally locked in place, with only one side facing us Earthlings. You add it all up and there's not much consistency. One planet spins nearly 600 times faster than another, two of them spin backwards compared to the rest, and one of them is on its side. They all pale in comparison to a neutron star, though, like this one, which spins 716 times a second. Kind of makes it glad Earth isn't trying to actively throw us out into space, at least for now. For this week's Moment of Science, I'm Dan Smith.